Hello everyone. Right, we're going to carry on with our differentiation and calculus work, and today we're going to be comparing differentiation process with using a graphical method, basically plotting a graph and working out gradients that way. So first of all, let's just remember what we're doing. Differentiation is all about finding the gradient equation, which we call the derivative. We then, once we've got that gradient equation, we can put any number for x into that equation and it will give us the gradient at that point. And when we find the gradient of a curve, we're really finding the gradient of a tangent. Now those things are quite important, so let's look at the two methods. We're going to look at the graphical method first, and then we're going to look at differentiation second. And we're going to compare them. So first of all, the graphical method. Now the graphical method basically says to work it out, we're going to plot the graph. So we have to get some graph paper, or we can use a computer system. We need to plot the graph. Then we need to draw a tangent at the point we want to find the gradient at. Then we've got to identify 2 points on the tangent line. And once we've got those 2 points, we can find the gradient between them. So what we'd end up doing is something, let's say for a question like this, let's say the question said y equals 3x squared minus 10x, and we want to find the gradient when x equals 4. So what we would do first is first of all plot the graph. Now that could obviously take quite a while. If we're doing it on a computer, it's not bad. So there's the graph, that's y equals 3x squared minus 10x. The next thing to do is we need to find where we're going to find the gradient. We're going to find the gradient when x equals 4, so we need to draw a tangent to the curve when x equals 4. So that's what it looks like. I've just drawn it in black there, and then that's our gradient really. We're trying to find the gradient of that line. So to find the gradient of a line, we did this right back in the first assignment. You need to now do 2 points, find 2 points on that line, try and make sure they're not too close together. So I've chosen 2 points, which are those two. Basically when x equals 3 and when x equals approximately 4.75. In order to work out the gradient of that line, we need to first of all write down what those coordinates are. So the 2 points are 3 minus 5. That's the lower point, and then 4.7519 is the higher point. Once we've got those 2 points, we now need to work out the gradient between them. So you first of all call one of them x1, y1, and one of them x2, y2. Once you've got those two, you can then plug them into the equation. The gradient is the change in the y divided by the change in the x. Put the numbers in, and we get an answer of 13.7. So that's one method of finding the gradient of a curved line. Right, so now we look at the second method, and this is the differentiation method. We've been doing differentiation over the last few weeks. The differentiation method is pretty straightforward. To find the gradient of a curved line, we need to first of all find the gradient equation, the derivative, by differentiating the equation. And then we can put any value we like into that. So here's our same questions we had in the previous example. So first of all, we need to differentiate y equals 3x squared minus 10x. And hopefully you can do that fairly quickly. We multiply the power with a number in front, and then we reduce the power by 1. So it becomes dy by dx is going to be 6x minus 10. Now we've got the gradient equation. We can now put any value we want. Now the question said find the gradient when x equals 4, so we just need to put 4 into that equation. There's no point putting 4 into the first equation because that would just give us the y value when x equals 4. We want the gradient, so we need to put it into the second equation, the dy by dx equation. And we get dy by dx equals 6 times 4 minus 10. And if you do that, you get the answer 14. That's slightly different to the answer we got when we did it by graphical method. And the graphical method came out as 13.7. And that's mainly because it's less accurate. So let's compare the two methods. So here they are side by side. If you look at the first side, we've got the graphical method. We had to plot a graph, we had to draw a tangent, we had to find 2 points, and then we had to find the gradient between them. And the second method, which is on the right hand side, is the differentiation method, where we had to differentiate the equation, put the number in and get the answer. Now, the first method involved drawing a graph, the second method didn't. We didn't even need to know what the graph looked like. We could just simply differentiate and put numbers in. Hopefully you can see that's a lot easier. So just comparing the two methods. The graphical method is probably easier to understand because you can see what the graph looks like, you can see what you're trying to do, but it is much more time consuming. It is actually less accurate. If we actually look back at the answers, one of them came to 13 point something and the other one came to 14. It was the 14 answer which is the correct answer. The differentiation method is absolutely correct. The graphical method, it varies, mainly because it depends on the accuracy of the drawn tangent. And one of the other problems with the graphical method is it only finds one tangent at a time. You have to draw another tangent and then draw 2 more points and then find the gradient between those 2 points. Whereas the differentiation, we just put a different value into the dy by dx, the derivative. So both methods do find the same thing, but calculus and the differentiation method is much faster and more accurate. Okay, so what I want you to do now is you can keep this slide open and you can freeze it later on. But if you look at the task, I want you to read your notes, page 10. It will basically be very similar to slide 6 of this PowerPoint, where you just see the two methods side by side. You're going to do both methods. So you're going to do the graphical method, and you're going to use Desmos to do that, to plot the graph. Then you have to print that out and draw a tangent line in, find 2 points on the tangent line, and then work out the gradient between them. And then you're going to do it by differentiation, which obviously is going to be quite quick. When you use Desmos, there are a few rules, and I've written them down here on the slide. So, so the first thing, on that page 11 of your notes, it says to use autograph. We're going to not use autograph, we're using Desmos, and that's at that website showing there. Secondly, you can't draw a tangent like you can do with autograph, so you're going to have to print it and draw your own tangent. When you plot the graph, you have to plot it as y and x, even if the equation is v and 2. So I've given you some examples here, and please read them carefully. It's important that you work out how to do this properly so that you type in the right equation. If you type in the wrong equation, then you're going to waste time doing the wrong graph. Okay, have a go and see if you can get the two answers, one the graphical method and one using the differentiation method.